So glad you asked about this problem. 2010, number 5. It seems like one of those that's doable, and then the answers kind of throw you for a loop. So definitely worth looking through some of the nuance of it. If you couldn't follow especially like the Euler's method, how they go about doing it, it's kind of in symbolic notation. So if you want to work through, excuse my yawn. Oh, it's been a big weekend. Anyway, if you want to make a table, that's fine. They'll read the table. They just did notation in there that's symbolic and short, so that it's easy to pass out to graders, things like that. But the biggest thing is you want to get your step size, and notice that you're starting at x equals 1 and f of 1 is 0. So those are the first 2 points, 1, 0. And then dy dx is what you get from plugging your, if I put 0 into the derivative, because that's what I have at my initial value, it's 1 minus y, and so I put 0 into 1 minus y, and I get 1. Then I take that dy dx, basically my slope, times the delta x, which is, since I'm going from f of 1 and I'm supposed to approximate f of 0, and it says do it in 2 step sizes of equal value, that means I'm going down 0.5 each time. And so negative 0.5 and negative 0.5 are the leaps that make this happen. And that's important to notice it's negative, because it incorporates itself into, when I do dy dx, which is my m, times the change in x, that dx, which is negative 0.5, that I'm changing my y ultimately by negative 0.5, so my new y is 0.5. Okay, so at the end, that negative dx thing, it makes a difference in understanding that can happen. You can go backward. Your change can go forward or backward. New y then is negative 0.5. You use that in your dy dx, 1 minus that, which is actually 1 plus 0.5, so it's 1.5. Then you take that times dx, which is our negative 0.5, and we get negative 0.25. Take that and add it to our previous y, and makes negative 0.75, or, yeah, I think I got all this in there. Yeah, look at my numbers. Negative 0.75 added to negative 0.5. Gives me negative 1.25, and I think I had some other numbers written in there because I'd scribbled and written fast, and I fixed it really fast. And then my new y then is negative 1.25, and that turns out, when I carry it down, that's my f of 0, my approximation of it. And that's the answer that's also on the exam booklet. Part B is, might be a tricky one to notice. You always want to start by plugging in your limit value. So limit as x approaches 1. Stick it in there. Since it's a BC exam, there's a really good chance that what you're going to have is a L'Hopital problem. Even in the symbolic form, when I put 1 in directly to f of x, f of 1 is 0. When I put it into the denominator, 1 cubed minus 1 is also 0. That's 0 over 0, and we want to do L'Hopital to evaluate this limit, which is to derive the top and the bottom separately. So I'll let her rip. Here it is. The derivative of the top, f prime of x, which is fine, and the bottom, 3x squared. And this is a good thing, because f prime of x we have. It's dy dx. It's that differential equation we had in the beginning. We can put in 1 directly, because this is a limit at 1. And if you put 1 in, you can't put it in to the derivative directly, but f prime of x equals 1. It means we got to plug in 1 into, so here it is, dy dx, 1 minus y. We know that the y itself is f of x. And always kind of goofy, but y and f of x get interchanged a lot, especially on the AP exam. But you put f of 1 in there, you get out 0. We knew that from the beginning. So that means we can put in 0 for that y value in the numerator. F prime of 1 would be 1 minus 0. And then on the bottom, we could put 1 in directly and just get 3 times 1. So ultimately, we get 1 over, 3 times 1 squared, which is 1/3. That's the limit. Next piece, part C, you have to divide both sides by 1 minus y. I mean, the idea is you want to get y on the left and x on the right, but you can't do it additively. You can't add y, because then on the left-hand side you'd have dy plus y, and that doesn't work wouldn't allow us to integrate it. So multiplicatively, you need to move y to the left and x to the right. Nothing additive will work. So I've copied this over to a new page because it takes a little more work. If you integrate the left, I didn't throw that in there, but I can, so I can put an integral up here. There we go, integral on both sides. when you integrate the left, it's if you notice a little u substitution. It's natural log, but because it's a negative y, you have to put a negative out front. And then integral of x, or 1 is just x, plus c. Now, treating this negative outside of the log, that could be tricky. You can do a couple things. You can, throw it into the log itself and make it 1 over, because it's, to the negative 1. 1 minus y to the negative 1 would mean 1 over 1 minus y. That seems kind of hairy to me. So what I'm going to do is actually pass it over to the other side of the equation, make it negative x minus c. And negative x minus c really is, because we don't know what c is, we could just change it back to plus c if you want, so that's no big deal. And then e to the negative x plus c equals 1 minus y using the log rules. Then when you have a plus c in your e exponent, you want to put it up front. And you subtract y 1 from both sides, then pass the negative back. And, there's this issue of, technically, I would have a negative in front of that c there, since I'd be passing the negative up here in this equation over to the left. But because we don't know what c is, we could leave off the negative. It's unnecessary. So we'll just back that off, and it's just c. And then if you finish this out, the idea is to find out what c is by putting in the initial condition. We know f of 1 equals 0. So x is 1, y is 0. And we solve, and to get c by itself, I have to multiply both sides by e to the 1, since it's e to the negative 1 that I'm trying to get rid of. Think of that as 1 over e to the negative 1, so multiplying both sides by e would take care of it. And then that means c is negative e. And if I plug that back in there, this is kind of what I get, and tidy it up a little bit. I think if you look at the answer choices, it has these swapped 1 minus e to the negative x plus 1, but all the same to the AP examinee, or examiners. Let me know if you have other questions. Hope that was helpful. Best luck.